Good morning. Now we are going to solve the second question, that is from unit test 1, and we have calculated the tensile strength of two ISA 75-75-8 connected on either side of gusset plate. Now keep in mind, if you will see question 1, in question 1 you have not given the number of boards, whereas in this number of boards are not given. Then how we will go for this? So now we will start with tensile strength is, so we have to go for yielding and rupture only. So we have tensile strength is minimum of, tensile strength is minimum of, we have one yielding of cross section, yielding, that is TDG, and second we have rupture, that is TDN. So now we will first go TDG, and we have formula TDG is equal to AG Fy upon gamma m. Now we have two ISA. So now you can go with 2 over here, or you can find and then multiply it by 2. It's okay. Now 2, value of AG for 75-75-8 is 1140 into 250 divided by gamma MO is 1.1, and we have this value that is equal to 518.18 10 raised to 3 newtons, and that is 518.18 kilonewtons. And now we have to design connection for this value. So now we have connection. So connection. So now we have VD as B. So we have FU, actually this is FUB upon root 3 gamma MB in bracket NN AN plus NS ASB. So we have this value is 400 divided by root 3 into 1.25 in bracket. Now as it is two angles, so we have double shear. So connection NN equal to 1, NS equal to 1, because we have double shear. If single angle is there, then we have single shear. But if we have two angles, then we have double shear. And then we have NN is 1 into 0.78 into pi by 4, 20 square. So we are going to assume 20 diameter bolt. D equal to, diameter of bolt equal to 20 millimeters plus 1 into pi by 4 into 20 square. And from this we will get value of VD SB, and we have this value, just I will calculate it. So 105.89 divided by 105.89 divided by 410 multiply by 400. 103.31 kilonewton. Just calculate it. 103.31 kilonewton. Then we have VDPB 2.5 kb dt Fu upon gamma ml. Now we have E 1.5 into dH. So dH, what will be value of dH? So dH equal to 20 plus 2, 22 millimeters, table 19 we have. And then 1.5 into 22 will be 33. Therefore provide E40. Then we have P equal to 2.5 into D, diameter of bolt. This is pitch, and it will be 50. Go higher side, therefore P equal to 60. Now for KB, we have 3 upon DH. So E we have 40 divided by 3 into 22, diameter of hole. And we have this value 0.61. Then we have P upon 3DH minus 0.25. P we have 60 divided by 3 into 22 minus 0.25, and we have this value that is equal to 0.66. Then FUB upon FU, we have 400 upon 410. This value comes 0.98 and 1. Minimum of this will be KB, and therefore we have KB equal to 0.61. Now put all these values in this equation. So we have 2.5, 0.61, D is 20, T we have 8 mm. So one side we have 16. So thickness of gusset plate will be 10 mm, greater than your thickness of angle. If you have single angle, then T will be of single angle. If you have double angle, then T will be of gusset plate. Into FU 410 upon gamma ml 1.25. And then we have this value VDPB, that is equal to, I got this value 100.04 into 10 raised to 3 Newton, that is equal to 100 kilonewton. And therefore we have, therefore number of bolts equal to, now we have value of TDG, that value is 518.18 upon 100, and that will be equal to 5.18, and therefore provide 6 bolts. Now formula for TDN, second we have TDN, and formula we have TDN equal to 0.9 ANC FU upon gamma ml plus beta AGO Fy upon gamma m. Now we have ANC D. Now I will not write formula. We have D minus T by 2 minus N into DH into T, and value of ANC we have 392 millimeters. We have AGO 75 minus 8 by 2 into 8, and we have this value 568 millimeters square. Now for beta, we have 1.4 minus 0.076 W by T Fu upon Fy Bs upon Lc. And now in this we have W 75, Fu that we know, T we know, Bs equal to W plus Wt minus T. Now Wt we know 0.5 to 2.57 into 75, and we will get into 75. So we will get this Wt, we have 40 millimeters. So it comes in between. So I have taken Wt as 40. So we have W75 plus 40 minus 8, and value of Bs 107 millimeters. Now LC, distance between the two boards. We have six boards. So 1, 2, 3, 4, 5, and 6. So we have 5 pitch. So we have this will be 5 into 60. 60 is pitch. So if we have 6 boards, then we have 5 pitch. So LC equal to number of boards minus 1 into pitch. Number of boards minus 1 into pitch. And therefore we have this will be 5 into 60, 300. And now put values. So we have beta equal to 1.4 minus 0.076 into W by T in bracket 250 upon 410 into BS we have 107, LC we have 300. And from this we will get value of beta equal to 1.25. And from this we can find TDN. We have 0.9 into ANC is 392, FU is 410, gamma ML is 1.25, beta is 1.25, AGO 568 into 250 upon 1.1. And from this we got this value that is equal to 554. So we have to multiply it by 2. And then we have this value 558.16 into 10 raised to 3 newtons, which will be 558.16 kilonewton. So minimum of TDG and TDN. Therefore, TD equal to 518.14 kilonewtons. So tensile strength of 2 IS 8 75 is 518.14 kilonewtons. So this is one, that is analysis. Now go for design. So design a double angle section tension member connected to each side of gusset plate, carry axial load. So whenever axial load is given, we have to make it factorate. TU is equal to 1.5 into T, 1.5 into 280. So it will be 420 kilonewtons. So now we have to go design of this section. So we have to find AG required. So we have AG required. TU into gamma MO upon Fy. Now we have TU 420 into 10 raised to 3 into 1.1 upon 250. And then we have this is equal to 1848 millimeter square. Therefore, AG required for single, that is equal to 1848 upon 2 is equal to 924 millimeter square. Therefore, select two angle. So I have taken these angle sections as angle 65, 65, 8. 65, 65, 8. And we have area of this is 976. AG provided 976 millimeter square of single angle. So now tensile strength, minimum of tensile strength, minimum of one is TDG, another is TDN. Therefore, we will go first, yielding of cross section, yielding TDG, and we have formula TDG is equal to double angle we have. So AG provided Fy upon gamma m. So now we have 2 into 976 into 250 upon 1.1, and we have this value comes 443.64 kilonewtons, greater than 420 kilonewton. Therefore, okay. Now you can have this multiplied 2 here, or you can be at the end. That is your choice. Then we have second. So just wait, what is happening? I can't understand. So, okay, then again I will share it. Now we have to go for connection, and for this connection, we have diagram for this is in this fashion. So we have value, this will be L1, and then we have value will be L2. So we have this will be L1 and this will be L2. Now we have connection. Now it is given 6 mm weld connection. 6 mm weld. So we have weld strength per millimeter. Weld strength per millimeter. And that is equal to 0.7 S Fu upon root 3 gamma mw. Now substitute values. So we have 0.7 into 6 into 410 upon root 3 into 1.25, and this value we have seen 795.36. And then we will take moment about L20. Now we require centroid of this, and we have 18.9 centroid of this. So this value. So this is 18.9. Now we can have moment about L10. Then we have 795.36 into L2. So we have force over here in opposite direction. And then multiply by distance. So we have this total distance 65 angle section. So into 65. That is equal to, we have this force that is given 420 kilonewton. 420 into 10 raised to 3. And then moment is about 11. So we have to multiply it by 18.9. And therefore we will get value of L2 is 153.54. Now we can have moment about L20. And then we have 795.36 into L1. This will be strength of weld. Again multiply by 765, and which is equal to 420 into 10 raised to 3 into we have 65 minus 18.9. We are now moment about this. So we have to take this distance, which is 65 minus 18.9. And then from this we will get, therefore, L1 that is equal to 374.52. And therefore, provide provide L1 equal to 380 millimeters and L2 is equal to 160 millimeters. And from this we will get LC, which will be L1 plus L2 upon 2. And that is 380 plus 160 upon 2. And we have this is equal to 270 millimeters. Then we have BS equal to W, which is equal to 65 millimeters because we have welded connection. And then we can find TDN equal to 0.9 ANC FU upon gamma ml plus beta AGO Fy upon gamma m. Now ANC we have ANC equal to AGO equal to, because welded section we have both same, B or D minus T by 2 into T, and we have this value 488 mm square. And now put these values. So we have 0.9 into 488 into 410 upon 1.25 plus beta we have not calculated, so we have to calculate beta also. So all values we know, 1.4 minus 0.076, W is 65 upon 8, 250 upon 410, BS is again 65, LC we have 270, and you from this you will get beta equal to 1.31. This is less than 1.4 and greater than 0.7. So plus 1.31, AGO we have 488, FY we have 250, gamma MO is 1.1, and we have double angle section, so we can multiply it by 2. And from this you will get value of TDN, and that is 578.7 kilonewtons. And this is also greater than 420 kilonewton. 420 we have TU, and therefore cell. Likewise, you have to solve the problem. Now we will stop here only. Thank you.